Good morning. Today we're going to study the law of cosines. The formula here is also given to you. There is actually two uses here for the law of cosines. If you have two sides in the included angle like yesterday, yes, you can find the area of the triangle, but come to find out, you can find the third side. So once again, as we continue with those trig congruents, side angle side will not only give you the area of the triangle, but you can use it to find the missing third side. And the formula, remember, the lower cases are the sides. So c squared equals a squared plus b squared. Kind of looks familiar to you, doesn't it? Pythagorean theorem. Minus 2, the side A, the side B, times the cosine of angle C. So the way this works is, if you have the angle, so I'm going to label angle C as 102 degrees. Then you have the two sides, so let's say A is 21 and B is 21. Side C is opposite the angle they give to you. So once again, with side angle side, you can find the missing third. But ironically, what's interesting is very common number 2. It's a little lengthier, but this particular formula will also help you to find an angle and then possibly the area of the triangle. See, this here is kind of a continuation from yesterday. It's really super easy to find the area of the triangle. So what IB does to make it a little bit more complicated is, what if I give you all three sides? Then you must use this formula very carefully to find the missing angle. And then, of course, you know, they like their part B, part C kind of questions, and etc. Then they'll have you find the area of the triangle. So we'll take a look at some of the questions you might face. And then I'll also share with you, with the notes, the answers to last night's and tonight's homework. Okay. So let's take a look here. Number 1, straightforward. We have the two sides, which I labeled A and B, which you could have reversed if you wanted, but you can't reverse the angle. That is definitely angle C, and we're trying to find the missing side, so I labeled the missing side here C. So using the law of cosine formula, we start off with C squared is equal to 21 squared plus 15 squared minus 2 times 21 times 15 times the cosine of 102 degrees. Now, all you have to do is substitute this into your calculator, but remember, the mode should be in degrees. So once again, where I pick up here from my calculator, press, there you have it. You have no idea what mode the calculator is going to be in unless you take the moment and check, especially if you're borrowing, next school year, a calculator. So here I go, 21 squared plus 15 squared minus 2 times 21 times 15 times the cosine of 102 degrees. Close your parentheses. You'll get a big lengthy number, no problem. So I get here, C squared is equal to 796.9843652. You'll notice I didn't round yet because I'm not done yet. I want side C, not C squared. So, like the Pythagorean theorem, how do you finish off here? You got it. Take the square root of both sides. So there's a couple things you can do here. This is the last answer that's been solved and stored in the answer feature. ANS is a button that's shared with a negative sign. So if you press second, that negative sign, there you go. There's the number. It's stored right there. So second x squared, second ants. It takes that answer and substitutes it in, and voila. Some people like storing. So once again, where do you store? There's your store button, and you pick the X variable button. That works wonders too. And now I can round 3 sig fig, since they didn't tell me anything else, the answer would be 28.2. So side C, 28.2 units. That's a pretty straightforward law of cosine scenario, where instead of finding the area of the triangle, they're asking you to find the missing third side, side angle side. Now let's take a look at the more complicated that they could very well ask us. And here's a two-parter, example number 2. We have a triangle and has lengths sides 11, 12, 13. First they want me to find the measure of the largest angle. That brings me back to the days of geometry. And this is also on the SAT don't know what the status of SATs are. Be kind of interesting if anyone knows. So 11, 12, and 13. I'll label my three sides. Just a sketch, nothing terribly fancy. But now I have to think about, where would the largest angle hang out? My days of geometry tells me the largest angle is always opposite the longest side. So 13 is the biggest number. Guess where I'm going to label angle C? Right here. So if that's angle C, this is side A, let's say, and this is side B. And of course you could reverse those, but you cannot reverse this. Side C, the longest side is 13. Okay, so that's super important. Of course, they could have interchanged this and substituted in instead smallest, right? So if they wanted you to find the smallest angle, where would you have labeled angle C? Right here, opposite side 11. Okay, so I digress. But anyways, now, this is my recommendation. Write the formula. C squared equals A squared plus B squared minus 2AB cosine of angle A. Fill in what you know, okay, especially since this is one of the more challenging multi-step problems. So 13 squared equals 11 squared plus 12 squared minus 2 times 11 times 12 times the cosine. Oh, why did I put angle A? Oh, silly me. Angle C I'm trying to find. So cosine angle C. All right, see how this is kind of awkward? We are going to have to try the best here, clean this up with as much PEMDAS as possible, but ultimately we want to get cosine C by itself. So let's do what we can. 13 squared is 169. Let's see, what is 11 squared plus 12 squared? Well, 11 squared, okie dokie, is 265 here, minus, okay, now we need to take 2 times 11 times 12. 2 times 11 times 12, 264. So that's 264 cosine angle C. Now this is where things start to get a little cuckoo for some people. You cannot subtract these two. 264 has to get multiplied to the cosine angle C, which we still don't have. So what can we do at this point? Well, 169 over here and 265 are like terms. So what I'm going to do, I'm going to subtract 265 from both sides. Now when I do so, 169 minus 265, I get negative 96 equals negative 264 cosine angle C. So now, do you see why we had to do the trig equations unit before? We're going to divide both sides by the negative 264, and it turns out the cosine of the angle trying to find is equal to the fraction 96 over 264. Now, it's okay if this is a negative number. Don't freak out. If this ends up being a negative number, that's okay, because when you use the calculator, I'll show you this in a moment, you're going to get an obtuse angle, because cosine in quadrant number 2 is negative, and you can have an obtuse triangle, not a problem. But here, since the negative divided by negative I know cancels, I didn't even bother reducing a fraction because I'm really trying to find the angle measurement. If I go to my calculator, second cosine, 96 divided by 264. I feel like using the fraction feature, that works. I'll show you that in a moment. So second cosine, second y equals, nope, that's not right. Alpha y equals, missed it entirely, number 1. You could type in the fraction like this, is fine. Close your parentheses, and voila, there's the angle. So here the angle would have been 68.7 degrees. So it looks like we're going to have, I mean, down the road, this is a scalene triangle, and because all three sides are different, and it's going to end up being an acute scalene. Not that you need to know that for the IB, in case you do have to still take the SAT next school year. So now, just to point out again, if you had a negative number, let's say you had negative 96 divided by 264, nothing to freak out. You'll get an obtuse angle. So that's okay. Now, once you have that missing angle, can you find the area of the triangle? Sure, fill in what you know. 11, 12, 13. And this angle we just discovered, 68.7 degrees. Quick review of yesterday. How do you find the area? 1/2 the two sides, 11 times 12. The area formula is sine 68.7 degrees. I kid you not, when this used to be on the Regents exam for 11th graders or accelerated 10th graders, formula was given, and he would still write cosine. So use your formula sheet. You don't need to memorize them. Okie dokie. So off to the calculator go, 0.5 times 11 times 12 times the sine of 68.7. I get here's the area 61.5 units. That's a common problem. That's I'm going to guess about 7 to 8 points. So on the IB exam, you should be able to finish this with 7 or 8 minutes max, less if possible, to save time for the calculus questions, of course. But these are pretty much the basics of this topic, law of cosines. How can the problems get a little bit more advanced, you might think? Well, let me share with you. Sometimes, and I have not seen this on the IB exam recently, and it gets changed. They self-review every 5 to 7 years, so it's been a few changes. So I haven't seen this lately, but I have it here. I want to make sure I cover it just in case. But sometimes they want the exact value. You got it. Look, you see, you have the two sides. There's a missing side missing in the angle. Take a look here. If they insert the word exact, can you guess what triangle they want you to perhaps use? You got it, the 30, 60, 90 triangle. So don't forget your ratios. I'll put this here off to the side because it's been a little bit of a while here. So when we work with a 30, 60, 90 triangle, I typically use the 1 radical 3, 2. And remember, we're 60. 60 degrees is here. So 60 degrees is here. You can imagine we're going to need the cosine of 60 degrees, which is 1/2. So keep that on the side. So if we're trying to find the exact value, we must use the law of cosines. That's a definite, LC, law of cosines. So there's the angle, C, so this must be side C. We can interchange the A and B, but you can't, since this is the angle they give to us, that must be side C. So we will start off with 7 squared equals 6 squared plus x squared minus 2 times 6 times x times the cosine of 60 degrees. Now 7 squared is 49, 6 squared is 36, plus x squared minus, let's see, 2 times 6 is 12. The cosine of 60 is 1/2, so what's 12 times 1/2? 6, and the x is still there. Okay, if I clean this up, I'm going to subtract 49 from both sides, and this is what I end up getting. X squared minus 6x and 36 minus 49. 36 minus 40, I get negative 13. Interesting. Whoa. How do we solve a quadratic equation? We factor it or quadratic formula, which we've just had practice of that on the last chapter, right? This doesn't factor, so guess what you're forced with? Quadratic formula. So x equals negative b, so 6. Plus or minus, won't hang around too long. We're going to have negative 36 squared is 36 minus 4 times 1 times a negative 13 all over 2 times a. 2 times 1 is 2. Now, we're talking about a length of a side of a triangle. So it would not make sense for us to keep the minus, I'm sure. So we're probably going to keep the plus, but we'll confirm that in just a moment. 36 here minus 4 times 1 times negative 13. Straight PEMDAS. So 36 minus 4 times 1 times a negative. Remember using negative numbers with our Texas Instrument calculators. 88. Okay, 88. Now, let me just take a look here. Square root of 88. Is that bigger or smaller? Yeah, let's see. that square root of 88 is much bigger than 6, so it doesn't make sense to keep the minus. So we're going to reject it right away, all over 2. Now, they do ask the exact answer, so we might need to review simplifying radical. So how do we break down the 88? 4 and 22, you got it. Square root of 4 times square root of 22. So this will be 6 plus 2 square roots of 22 over 2. Oh goodness, look at here. We have the 3 Musketeers from September. Remember, if these 3 numbers have a common factor, divide them all by the GCF. So our final answer is going to be 3 plus the square root of 22. That's your final answer. What gives? The word exact. If that word exact is in the picture, unfortunately, you must leave it in simple radical form. Now, you're probably wondering, oh my gosh, we're always going to do quadratic formula. Well, the 4 problems I gave to you for homework this evening, 2 of them will lead to the quadratic formula. But later on in this chapter, I did find an example that does factor. So it's not always the worst case scenario, but it's not like something you've never done before. And like I said, I saw this on an old IB exam, but that was many changes ago. So it's there. Might as well review as we finish off the course. So I do have an exit ticket. Now, this one here does say exact value, and as you can see, 120. In case you're a little rusty, when you work with a quadrant 2 angle, what do you know about the cosine? Yes, it's negative. So the cosine of 120 degrees is, reference angle 60, negative 1/2. So I will work on this, and then I'll send all this here to you into either, actually probably do both, Remind and Google Classroom. If you have any questions, just shoot me an email or message me. Thanks. Have a great day.